Alright, and welcome to Rotations Level 3. Now in problem number 1, it says find the surface area of the three-dimensional shape created when rotating the triangle below around the AB axis. Okay, so notice here, let me go ahead and switch to just a different color one we can see a little bit better. Here is the AB axis, and remember, when you're rotating around this axis essentially nothing changes on it. But it's going to be this point C, which will in fact rotate continuously around that. And remember, all rotations, these points will always form circles. Now from here, if we were then to connect a line over here, it becomes very obvious that when you rotate a triangle, you're always going to create some form of a cone. Now this question is asking us to find the surface area of this cone, and we're going to need that formula. So we know that S, surface area, is equal to pi r L plus pi r squared. Now this is a fairly straightforward formula, however there's going to be one tricky thing. So let's go here, here's our pi. We know that our radius, we see that here, is BC, that's going to be 5. And we actually don't know what L is. L is this slant height. And we'll come back to that in a second. Let's just go ahead and fill out the rest of this. Pi. And then of course we know our R is still going to be 5. But let's go back to L. How could we possibly find out L, the slant height? Well, look here. Our height and our radius help form that original right triangle. And L is the hypotenuse. So we're simply going to use our formula. A squared plus B squared equals C squared. Okay, so since 10 and 5 are the legs of this triangle, we can just write 10 squared plus 5 squared equals C squared. And these are actually fairly easy numbers. You know these. What is 10 squared? 10 times 10 is 100 plus. What is 5 squared? 5 times 5 is 25. And this, of course, equals C squared. Well, 100 plus 25 is 125 equals C squared. And all you have to do to get rid of a square is to take the square root. And so you go to your calculator, let's take the square root of 125, and it turns out C, or in this case, I guess we could actually call it L, our slant height, will be 11.18. Going back to our formula, we'll plug that in, 11.18. And now we can go ahead and tackle this. Now what I would do if I were you is I would tackle these as separate parts. Okay? So I would do pi times 5 times 11.18. Of course this will give us 175.60. You know what, actually let's go up 3 digits, 615 plus. And over here we have pi times 5 squared. Now 5 squared, you know that's 25, so 25 times pi will give us 78 point, and I'm going to do 54 since I'm running out of room here. Okay, it's a little hodgepodge rounding, but we have 175.615 plus 78.54. And it turns out our surface area is going to be 254.16 rounded to the nearest hundredth. And of course its area, surface area, will be inches squared. Alright, go ahead, pause this video, finish taking any notes that you need to, and we'll go ahead and move on to our second example. Okay, here we have our second example. A right triangle is rotated around its height. What would the volume of the new three-dimensional figure be given a height of 9 and a hypotenuse of 12.8 inches? Okay, let's start by drawing our right triangle. So just a pretty generic, straightforward right triangle. We know that the height is 9, and we know the hypotenuse is 12.8. Okay, and it says it's rotated around its height. So that means that this line right here will not change. However, this point right here will be spun endlessly around that central axis. And notice if we connect this line over here when it's been rotated 180 degrees, of course, when a triangle is being rotated, it creates a cone. So the one thing that we see we're missing here, because we have our slant height, and here we have our actual height, but the one thing we're missing is our radius, r. So how do we want to find that? Well, we'll use our Pythagorean theorem, a squared plus b squared equals c squared. However, I'm going to manipulate it just a little bit. Since we're looking for one of the legs, I could write minus b squared, and essentially all we're saying is, hey, if we want to find one of these legs, we can simply do the hypotenuse squared minus the leg squared. It's a manipulated version of this, makes things go just a little bit faster. So we'll write a squared equals, our hypotenuse squared will be 12.8 squared, minus our b squared is 9 squared. Well, let's see what this gives us. So 12.8 squared is really 12.8 times 12.8, which is 163.84 minus, and you should know this one pretty commonly, 9 squared would be 81. So let's do 163.84 minus 81, and of course a squared will give us 82.84. Now, how do you get rid of a square? Well, we take the square root of both sides, and it turns out a equals 9.1. We'll just leave it there. Okay, so we now know that a equals 9.1, but what was that really? It was our radius. Okay, and we're asked to find the volume of this particular cone, and so I could just write this right here, V equals, and don't forget, for a cone or pyramid, the volume is always 1/3 times whatever it's going to be, and in this case it will be 1/3 times pi r squared h. So I can put 1/3 pi times our radius, which we just discovered was 9.1 squared, times this height of 9. And I know that's a little cramped. Let me draw that line there to block that off. Now, as always, when you start multiplying these things together, I would encourage you, do the 9.1 squared first. So 9.1 squared is 82.81 times 9 times pi. And of course, to multiply by 1/3, you can simply divide that by 3 if you're using a handheld calculator. And this will give us 780.47. And don't forget, whenever it's volume, we're looking for this in terms of, I suppose it would be inches cubed. Alright, I hope that these examples have helped you out, and good luck on the rest of this assignment.